Today, we're going to look at the normal distribution. We're going to look at normal distribution, one of the most important lessons on the distribution, probability distribution in quantitative methods. So to start with, when we are dealing with a normal distribution, this is one of the most important distributions in statistics. It is also known as a Gaussian distribution, which was mentioned or named after a French guy called Carl Gaussian. So he has contributed significantly to this study. When we're dealing with normal distribution is very widely used both in the natural and the science world to represent real valued random values where the distributions are not exactly known. So we must understand the characteristics of a normal distribution. So a normal distribution, as you can see, looks like this. It is asymmetric, meaning it's bell-shaped. It is continuous, meaning all values of x, it doesn't touch the base from infinite to infinite. So there are two parameters we must take note of. There's what we call the mu, which is a mean, and the standard deviation. All these are in the middle, the asymmetric, they're in the middle there. So the normal distribution uh, is defined by these two parameters, standard deviation and the mean. And the total area under this graph is 1, which represents 100%. So to calculate the probability distribution function, it is given by a formula. So it follows what we call the empirical rule. Between one standard deviation, this is 68%, two standard deviations, that is 95, three standard deviations, that is 99.54. So we use the formula Z is equal to X minus mu over standard deviation. If you are given a sample size, Z calculated is equal to X minus mu over the standard error. Standard error is simply given by our standard deviation over square root of n. So this is a very key formula that we're going to look at. So if you can see, we have approximately 68% of all the data that ranges between one standard deviation and mu. And we have 95% falling between two standard deviations and the mean, which is mu, and 99.7% which falls between these variations here. So this is very important to really take note of. So in our case, we consider what we call a standard normal distribution. So say the area under that graph represents the probabilities. These probabilities have natural applications. Okay, for instance, a natural phenomenon like
Sorry?
height. Yes, please.
Good afternoon.
Yes, good afternoon. Everybody hear
I
me?
know.
Okay, so I'll start with the basics of learning how to use our standard tables to understanding how to read these Z values. So the Z values are like an X-ray machine of a doctor. To understand and interpret, I usually like using that analogy. So you need to understand how to use these tables so much because they will help you determine quite a lot. So a Z table looks something like this. So you need to learn how to use um, a Z table. Let me just download it and I'll send it to you. Any questions so far before I proceed anywhere? Are we together so far? Okay, so we have what we call the Z tables. So they're used in calculating our normal probabilities. So if you're asked in this to calculate a Z reading of 2.57, for instance, the Z reading for 2.57, just give me a table for you. You'll be given these tables in your exam. You'll be given these tables in your exam, so you don't necessarily need to master the entire table. So the extract I'm going to show you just to illustrate how to read these tables. So we have what we call a standard normal table, which has both negative and positive values. So with these values, we're going to have the following. I'd have loved to start with a positive table, but it's still the same. Okay, so the Z table looks something like this. So if you're asked to calculate the reading of negative 1.45, negative 1.45, you go under 1.4, the first two digits here, and 0.05 here. So negative 1.4 and 0.05 there. So collectively, this is a reading here. So our probability here is 0.07353. Okay, who wants to try to give us a probability of negative 0.79? Can somebody help us? Probability of negative 0.79? Who wants to try? So try this one. What is 0.53? What is the reading?
0.294660.
0.29806, this one. Okay. So you're reading from here to there. Okay. So now, if you're reading from inside to outside, if I asked you what is a Z for 0.29806, you just go to 0.29806, just add this number 0.5 times 0.03, it gives you 0.53. So give me what is a Z for this probability? 0.016853. What is the Z for this figure? You just get this figure here, negative 0.96. It is 0.96. Are we following? You need to understand how to read from inside, and you appreciate how to read from outside. Are we together?
Yes, we are.
Okay. So can somebody give me what is the Z for 1.1? Negative 1.1. What is the Z for the reading of 1.1? Mm-hmm.
Should be 0 point, is it 13567?
So you go to exactly 1.1, then under 0. 1.1, then under what? 0. Okay. So 1.1 negative, and so this is the reading here. So here we're going to have 0.13567. Okay. So I say the probabilities, they represent the areas under graph. So we said the area under graph is equal to 1. So each side of the quadrant, here we have 0.5, and on the other quadrant we have 0.5. Collectively, we have what? 1. So this reading from here, I said 1.1 negative. It means the reading from here to here is what? 1.1. So this is 13%, 0.1356. Okay. So meaning the reading on the positive side, okay, 1.1 positive. So you should know that the reading from here to here is the same as the reading from here to here. But the reading from here to here, just subtract 1 from that. Okay? But you get the remainder. It is an easier way of calculating that. So if, for instance, the reading, let me use a logical explanation. If from here to here is 20%, what is the remainder from here to the other end? 80%, right? But how do you get the 80%? Simply subtract 100 minus 20%, or 1 minus 0.2. So that's the meaning, or in like manner. If the reading from here is 0.1356, so the reading is 1 minus the remainder. That is what the table will give you. Is that clear? So
Yes, it is.
that being said, I will move to the next point. So when we are standardizing the values of Z, we must learn to understand that we're simply standardizing to those values so that we're able to read what is in the table. Yeah, just reading so that we're able to understand what is in the table. So in the event that we are asked to say, suppose the value of mean is 10, the standard deviation is 3. Find the probability that x is greater than 7. So to start with, there's no 7 when you reach here. So 7 must be standardized. So the formula for standardizing is given by z is equal to x minus mean over standard deviation. So our x is 7 minus 10 over standard deviation, which is 3. What is 7 minus 10? It's minus 3. Minus 3 over 3 is equal to negative 1. So we're going to put this here, negative 1. It's here. So which sign are we going to shade? Greater means we shade to the right. Less means we shade to the left. So in this case, it says find the probability that x is greater than 7. So you must understand that the 0 is in the middle. It's a mean. It's always in the middle. Our 7 is here. So our reading is asking us to say greater than 7. So greater, we're shading to the right side. But when we go to the table, negative 1, it's a standard value of 7. When you go to negative 1, negative 1.0, what is the reading? 0.15866. 0.15866. So this means that the reading from here, 15866, reading from here to here is 15%. So can you help me? How do we find the reading on the unshaded region? We subtract 1 minus that, isn't it? 1 minus that. What are we getting? 1 minus 0.15866. So here you're going to get 0.84134. So total should give us what? 100%. I'm trying to be methodical so that I move step by step so I can understand what is happening. So this is just one side of the quadrant. Suppose we are actually asked to find the probability of x is greater than, less than 3. Find the probability that x is less than 3. So there are 3 steps that you need to understand. Find the probability that x is less than 3. What have we been given in the normal distribution? The normal distribution is usually in terms of the mean and standard deviation. So if they just give you n and either put 10 over 3, it means your mean is what? The mean is 10, is in the middle. The mean is 10, which when standardized is the same as 0. Then your standard deviation is 3. And you put our 3 this side here. So this 3, it is not just standardized, you need to standardize it. The formula for standardizing is given by x minus mu over standard deviation. So our x is what? 3. 3 minus 10, which is 7, negative, over 3. So 7 divided by 3, we get 2 point what? 2.33. So you need to read under 2.33. Okay, I don't have 2.33 here. Let me just assume this was what? X is less than 5, just for blood. So I'll put 5 there. 5 minus 10 is negative 5. Negative 5 divided by 3 is negative 1.666. If they are recurring, you need to put it in 2 decimal places. It's negative 1.67. Okay. So you read that. Okay. So suppose I had negative 1.33. I'm going to get negative 1.3 and under 3, this one here. So the reading here is 0.09176. 0.09176. So do we subtract from 0? No, we read it directly as it is. So it's a small reading here. So you need to understand, we use what is called ISA. Number 1, illustrate. Number 2, standardize. Number 3, illustrate, standardize, then here you apply. Okay, so you also illustrate, standardize, and apply. So let me ask if there are any questions so far before I proceed. And see a number of questions in the question bank. Oh, these were answers. Okay. Are we following?
Yes, it's clear, sir.
All right. So you must understand that illustration is very important. Understanding which table to want to use is very important. So I want to take you to the other table. It's the same table, just an extension. So here, suppose we're given our normal distribution setting with 10, 3. We are asked to find the probability that X is greater than 2. So using ISA number 1, we will illustrate. So our mean is 10. Our standard deviation is what? 3. Number 2, illustrate. Our illustration, the 2 is on the left side. Number 3, shade. Where we shade is determined by the sign that has been given. What sign do we have? Greater or less than? We have greater. So
Less
greater
than.
means shade to the
Because
right.
it's greater.
So greater means shade to the right. Then what does the shading tell you? The probability is big. Okay. So we will standardize now these two. How do we standardize? X minus mean over standard deviation. But X is what? 2 minus 10, which is 8 over 3. So negative 8 over 3. What do we get? Which is negative 2 point what? 67. 66666. You round it over to the next two decimal places. So we go to negative 6.27. What is the reading? 0.0038. 0.0038. So that is a reading from here to here. But what we're interested in is the shaded region. So the shaded region is big, so we subtract from 1 this small region here. So we subtract from 1. For 1 minus 0.0038. 1 minus 0.0038 to get 0.9962. So this big area here is 99.62%. All right. So this is how we understand the table. So I'm just dealing with the negative side so far. We also have the positive side as well, because we are told that it is asymmetrical. So whatever is on the left side is what happens on the right side. So suppose we're given our normal distribution 10, 3, and you are asked to find the probability that x is greater than 6, 8 is greater than 7. So let's use ISA. Illustrate. How do we illustrate? The mean, what is in the mean? The mean is in the middle here at 10. When you standardize the mean, it's always 0. Okay? Then we're going to put greater than 13, sorry, a positive number now. So 13 is on the left side, on the right side. On the right side here, 13. Then greater means shade on the right. So we're going to shade x is greater than 13, we're going to shade on the right here. So when we standardize this 13, what is the standardization formula? How do we standardize? Okay, so 13 minus 10 over 3, so which is 3 over 3, which is 1. So meaning the standard value of 13 is 1. The standard value of 13 is 1. So when we do this, it means that the area from here to here, when you go at 1 here, because all the readings are starting from here, this is a starting reading. When you go to 1.0, the area from here to here is 0.8413. 0.8413. But that's not the area we're looking for. We're looking for the shaded region. The shaded region, we subtract 1 minus that answer. So the probability will be 1 minus 0.8413. So when you subtract that, we're going to get the remainder, the residue, 0.1587. So this is how we calculate that. Are we following? Are we together? So this is how we do our regions. Okay. Any questions? Any questions? So now we can look at exam type questions. Okay, we can look at exam type questions. So we want to calculate the words that are synonymous, like um, greater, less than. We must remember them. So for exam settings, suppose we're given the following. Question number 1. A factory produces bags of potato chips that are supposed to weigh 50 grams each. The weights follow a normal distribution with a mean of 50 grams and standard deviation of 2 grams. What's the probability that there'll be more than 53 grams? What's the probability that they'll weigh between 48 and 52 grams? So the first pass here, we need to understand what we've been given. So our 50 is our mean, mu. Our standard deviation is 2 grams. So it's a normal distribution. So you can illustrate them. Find the probability that it will weigh more than 53. So 53 is on the right side. So more than means greater. So we're looking at this area here. All together. So using ISA, illustrate, standardize, shade, and apply. So we've illustrated, we have shaded. So now we need to standardize this 53. How do you standardize the 53? X minus what? Mu over standard deviation. Our X is 53. We put the 53 minus what? 50, put the 50 over the standard deviation, which is 2. So we're going to get 1.5. So this is equivalent to 0. This is equivalent to 1.5. So you read this from the table. 1.5, what is the reading for 1.5? 1.5 plus 1.5. What is the reading? And go to the positive side of the table. Under 1.5. Can you read through this table here? Can somebody tell me what's the reading for 1.5? You go under 1.5, 0. So this is 0.9332. 0.9332. So that's the reading from here. 0.9332. So if this from here to here is 0.9332, how do we get the remainder? We subtract from 1, isn't it? Are we together? So meaning the remainder will be 0.0668. So I'll end here for today. I'll give you questions based on this.